So, have that ready. They may need another couple seconds, find their notes. So I'm talking about these, right? So you have the little setup there. I will just let you know, I'm going to go back to basics where I do railroad track because it just works better in my brain. If you are having an issue seeing that and looking at it, then don't copy down what I'm doing. Do times in a line, all right? All right. So here's our paper. Limiting reactant worksheet. It says reagent, by the way. Reagent is just the same exact thing, all right? So we can call it reagents or reactants, whatever you want. It's the ingredients. All right. So before we dive into anything here, okay, and kind of if you relate it to the pictures that we were drawing yesterday, how will we determine a limiting reactant? What are the couple things that we know about limiting reactants? They what? They run out, okay? How can we look at the products and determine the limiting reactant? They have nothing left over in the product, okay, because they got used up. Good. If we looked at, I don't know where my drawings just went. I just had them. Sorry. The one that we were looking at right before, oh, here it is. Where you had your carbon dioxide, right? Okay, question. If we only paid attention to the carbon, how many carbon dioxides could have been made? 4, right? Only looking at the oxygens, how many carbon dioxides can only be made? 3, right? Every 2 oxygens got used for a carbon dioxide. 4 versus 3. Which one ended up being the answer in that one? The 3, right? Okay. It produced the least amount. Okay? So when you look at your stoichiometry problems today, you're thinking the one that creates the least. All right? So you might give yourself a little reminder at the top of your page. Forms the least product. Okay? Because when you get lost in your stoichiometry and all these calculations that are going to be on your paper, what you need to remember is the only answer that matters was the smallest amount that could possibly be made. The other one is irrelevant. It doesn't matter because it wasn't possible to begin with, okay? All right. So limiting reactant worksheet, we're going to be dealing with that. All right, so what we see at the top of our page is that we have our little equation. It is definitely not balanced, so just to balance this real quick, we have 1 copper, 1 copper, 2 chlorines, 1 chlorine. So I'm going to go ahead and throw a 2 right here on sodium chloride. So now I look here, I have 1 sodium, 2 sodium, so I'm going to go ahead and put a 2 in front of sodium nitrate. Now I have 2 nitrates, 2 nitrates, 1 copper, we're all good. So this is a 1, 2, 1, 2. Okay, so this is where I recommend that if you have the other sheet of paper ready to go, that's going to be what I'm going to be writing all my work on. I'm just going to write this at the top. So we're on number 1. I'm going to write our balanced equation out one more time. So if you want to get yours going at the top of your paper, it might be useful. If you don't, and you're going to write in that little itty bitty space there, that's up to you. But I would give yourself enough room to make sure you're going to be able to go back and study. All right. So what we're going to do is with all that hard work that we just got done doing, we wrote out all of our molar masses. We're going to write those molar masses underneath each of our characters here, okay? So molar mass of copper 2 chloride, you guys said, was 134.45 grams. Molar mass of sodium nitrate was 84.99. Oh, I want to address this real quick. Do we care about this coefficient when we're dealing with molar mass? No. Okay? What I started seeing on a couple people's papers was you wanted to put the coefficient in there. Don't do that. All right? Don't multiply it by 2 just because there's a 2 here. Molar mass is grams per 1 mole. All right. Copper 2 nitrate, we're going to have 187.55 grams. okay? Because you added together a copper, 2 nitrogens, and 6 oxygens, right? And then sodium chloride, we had 58.44. Perfect. All right. So now we can start looking at the problem. All right, so this is your letter A. Letter B was saying if 15 grams of copper 2 chloride react with 20 grams of sodium nitrate. How is this problem different from what we usually have been doing? How many givens are there? There's 2 givens. That sucks. All right? So you can't use both givens in one calculation. We're going to have 2 calculations. All right? For every single time that we set up this crazy little stoichiometry stuff, right, you can only have 1 given and 1 unknown. Never more than that. All right? So what I'm going to do is I'm just going to go ahead and put those pieces of information underneath our molar masses, or if you already took up that room, you can write them above it. We have 15 grams of this guy. We have 20 grams of this one. How much sodium chloride, that's still the same, only 1 unknown, right? We want to know how much of this one gets made. Okay? So far we don't really care about copper nitrate. Oh, all right, so if that's all our givens, then what that means is that we're going to be setting up 2 stoichiometry problems, right? 2 setups. And then how are we going to determine what the answer is? There we go. The one that forms the least. So the smaller answer of the 2 is going to be your final answer, okay? Good job. Nice work. All right, so let's go ahead and start this. Whew, fun stuff. Hopefully you have your notes next to you. Oh, there's mine. All right. So I'm going to go ahead and just go with what's in our notes. We're going to start with our given, okay? So I'm going to start with, and actually just to kind of point this out real quick, you're going to be doing one from grams of this to, we want grams of that. You're going to also do grams of this one, 2 grams of that. That's your 2 setups that you're going to be doing. You're going to be doing 2 of these, all right? There is a shortcut, but I'm not going to show you that because I don't want to totally lose you, okay? But you can talk to me later if you think you figured it out. All right. So what we're going to do is we're going to go ahead and go with what it's telling us in our notes. We're going to start with our given in grams. So I'm going to go ahead and put my 15 grams of copper 2 chloride. Right? Oh, I'm going to put a 1 right there. All right. Then I'm going to bring all of these words down to the right. That's going to ensure that I'm ready to go. All right, so once you bring words down to the right, now I'm going to look at my notes. All right, what it says in our notes, we've done our given. Now we're on the second step. We have 1 mole on top, so we can put in the 1 mole because it's a circled one, right? And it's still of this copper 2 chloride, so I'm not even going to write the label again. And then what goes on the bottom? The molar mass. So we're just going to pull from up here because we already did all that hard work. 134.45. Okay? All right, so that is step 2. We're going to the next one. Okay, I'm going to bring my words down to the right. This is still talking about moles of copper 2 chloride. This is our mole ratio step. Okay? This is our mole ratio step. So we have coefficients that we're going to have to pay attention to. Who are we going to put on top, though? Before we even put numbers in there, what are we talking about on top? We know that it has to be mole. Mole of who? Say that one more time. I'm so sorry. Who's the arrow pointing to? Sodium chloride, yes. Sorry. Did you say that? My bad. I'm having a really hard time hearing. I don't know if it's my congestion. All right. So what number are we going to put with our copper 2 chloride? A 1. Just looking at the coefficients here, right? So there's nothing there, so that's a 1. Okay. The one up here next to sodium chloride, what is the number that we're going to put here? A 2. We're grabbing it from there. Okay. By the way, is this one the same as this one over here? Like, are the ones the same thing? No, this one is a circle. This is the guaranteed one. This is the one that we pulled from our balanced equation. All right? All right. So that's our mole ratio step. So I'm going to keep going. Times in a line. I'm going to pull my words down to the right. So mole NaCl down to the right. Okay? We're on this last step. This is where we're going to have a 1 every single time, the circled 1, right? And then a molar mass is going to go on the top. So we're going to grab grams of NaCl. So let's go ahead and look up here. We already got that number, 58.44. Okay? So go ahead and get that typed into your calculator. And then if you'd like to start working ahead, if you kind of get the idea, just know that the next one that we're doing is now we're going to start with NaNO3. And you're going to be doing the same exact thing to solve for sodium chloride. So you can write that answer down. You should be getting something around 13 for both of these, just so you know, okay? They're not the same answer, though. But I'll go ahead and start writing my setup for this. So whenever you're ready to jump back in for the next calculation, go ahead and do that. But write your answer down, whatever you got on your calculator. And then we'll talk about it in a few minutes, okay? I'll write this one times in a line for my people who might be struggling with the thing up here. About 13 for both of them. What did you get for the first one? 0.04. Okay, yeah. That, no. So, I would make sure, here. Double check that you put the right numbers in. So for down here, you should have an 84.99 and a 1, right? Okay, and then here you should have a 2 and then a 2 above, yeah? And then here you should have a 1 and then that 58.44. Okay, there you go. So you can kind of check out the two setups, get your two answers.